And today in episode 1 we will measure distance by thumb rule. By the name we can easily understand that this is doing something with thumb. Yes, here we will use the thumb as a scope. First, we need to know one thing. We should be able to guess distance in meters for this method, because here the unit will be at meter. So let's get going. Now to start, choose the object you are going to measure the distance of. In our case, it's the tree. First, put your thumb just on the tree. Now this is impossible with two eyes open, because you cannot really focus correctly by two eyes. So we need one eye. So we will close one eye, which is in our case right eye. Now put your thumb in such a way that it's just on the object. Now don't you dare to move your thumb. Without moving, close left eye and open right eye. What can you see? You can see that your left eye was a lie. Your thumb is just almost a mile away from the tree. But that's the trick. Measure the distance between your thumb and the tree in meters. Now you can find it out easily by the conversion 100 cm is equal to 1 meter. And at last, multiply that by 9. You will get your answer. That's all, try it at home. And in the second episode, we will estimate height by T method. But first, for this method, we need some requirements, which are 2 bamboos or sticks. We need to align the sticks like a T, then tie them up at the middle. Remember, the second stick has to divide the first into half. So let's get into the scenario. We're going to measure the height of the tree. At first, hold the second bamboo at your nose. Then try to get the top and the bottom of the tree to coincide at the top and bottom of the first bamboo by moving away or in. Now if we see that in front view, it will look like this. First the lines didn't coincide, so we move away and stop when we cover up the whole tree. And then measure the distance from the tree to view. That's equal to the height of the tree. Season 1 episode 3, and we will measure distance by using German method. This method was used by German army, for which the name is German method. Here we will measure the probable distance from us to another person by only observation. Firstly, if we can see the person's face and eyes clearly, then he or she is at most 50 gauge away. If the eyes look like points, then he or she is 100 gauge away. That person will be 200 gauge away if we can see specific things like belt or button of shirt. His or her face will be blurry if he or she is 300 gauge away. We will be able to understand movement if he or she is 400 gauge away. And at last, if we can understand the color of his or her uniform, then he or she is 500 gauge away from us. That's all. It's the most simplest estimation as per us. Red Indian method is going to be enlightened in the episode 4 of season 1, where we will estimate the height. Again, as always, we will estimate the height of the tree. So let's get going. First, we need to look at the tree from between our legs. If we cannot see the whole tree, then we need to move away from the tree until we see the whole. Then we need to measure the distance from the tree to our current position. That distance is the height of the tree. Frankly speaking, that's it. This was used by the Red Indians. Today at episode 5.1 of season 1, we will estimate distance or length of a river via geometric method. Now 5.1 is just one process of following this method, and as a result, 5.1 and 5.2 are not solely related. 5.2 is just more complex. So let's dive into it. First, we have to find a static object at the opposite side of the river. If you are trying to measure the width of the river, mostly that static object is a tree. So suppose the tree is A and U are B. You have to move left or right, in our case left, at C. Now BC is just a random distance. At C, we have to put a stick or bamboo to identify that place. Then we have to move again to the left by the same distance, which will be equal to BC. So our current position is at D, whereas BC is equal to CD. After that, we have to move towards E. We will stop when the stick or bamboo coincides with a tree of opposite river. Or more easily, if we see that from our frontal view, it looks something like this. That distance of DE is equal to the width of the river. Today in episode 6, we are going to estimate height by shade method. Now from the name, you can understand that we need shade for this method, which means this method is only applicable in morning. And yeah, we also need a bamboo. So what are we going to do is compare bamboo's length and shadow and tree's shadow to find out the tree's length. First, put your bamboo in such a way that the shadow of tree and bamboo lies in the same line. Note that we have to know the bamboo's length, and that's what an ideal scout always should know. We're considering that as 90 cm. Then measure the length of the shadow of the bamboo, which is in our case 30 cm. Thirdly, measure the shadow of the tree. Now we can do that by using the bamboo. The shade of the tree is 1.5 of the bamboo, which is 135 cm. At last, we're going to use this tree information to find out tree's height. From the bamboo calculation, we know that for shadow 30 cm, in that scenario, our height is 90 cm. So what will be the height if the shadow is 135 cm? It's just grade 6 math, which is 145 cm. Let's recap again in an advanced way. Let us consider bamboo's height as X, shadow as Y, and tree's shadow as Z. Then in one line, the tree's height will be this. In one line or in one formula.
A little tips. Ooh, no, not money.
You can actually use yourself in replacement with the bamboo. It will be much more complex, but something is better than nothing. And today in episode 6 of season 1, we are going to measure height via inch to foot method. For this method, we just need a ruler or scale with inch measurement. First of all, we need to choose the object whose distance needs to be measured. In here, which is the tree. Secondly, we have to take 11 steps away from the tree. Then put a scale at that place. After that, take another step away. Now you have to lie down and close one eye. Then you have to see the top of the tree. Mark the place where the top of the tree and the scale coincides. Let the value of the scale where it coincides with the tree be x. Now convert x inch to feet. That feet is the height of the tree. Welcome to Scout and Scouting, where we learn scouting stuffs. Today in episode 9 of season 1, we will measure height via reflection method. In this episode, we will estimate height of this building. But before that, our requirements are a reflector like a mirror or a bowl of water, and a measuring tape or a rope or a bamboo which will be equal to the height of us from ankle to eye. Back to the scenario. First of all, we need to place the reflector at a random position C. Then place the bamboo in such a way that one end of it is at C and the other is at D. After that, stand at point D with attention position. Now without moving head, just look at the reflector with one eye. If you can see the top of the building in the reflector, then AC or the distance from the building to the reflector will be equal to the height of the building. If you cannot see the top of the building, then try the same process by moving the reflector away or close to the building. Welcome to Scout and Scouting, where we learn scouting stuffs. In episode 10 of season 1, we will estimate height by pencil method. For this method, we need a pencil, a scale, and we need 2 persons including you. Let us consider that we are going to estimate the height of the tree. First, one of the scouts has to stand under the tree in an attention position. Another scout has to go at least 50 meters away with a pencil in hand. Then he or she has to straighten their right hand towards the other scout. Now the pencil has to be in such a position that the top of the pencil is at level with the hand. Then he has to put his cheek at the shoulder and close left eye. After that, the scout has to see if the pencil aligns with the other scout's ankle. If no, the scout has to go back until it aligns. For simplifying things, we will see it in the eye of other scout. After we find the required position, the scout has to move the pencil up until it coincides with the top of the head of other scout. Consider that height as x centimeter. Then again move the pencil up until it coincides with the top of the tree. Consider that height as v centimeter. Consider that height as z centimeter. With the obtained information, we can make the following formula. Then just input the value and find out the height of the tree. Welcome to Scout and Scouting, where we learn scouting stuffs. And today, in episode 10 of season 1, we're going to measure height via decimeter to meter method. For this method, we just need a ruler or scale with meter or centimeter measurement. First of all, we need to choose the object whose distance needs to be measured. In here, which is the tree. Secondly, we have to take 11 steps away from the tree. Then put a scale at that place. After that, take another step away. Now you have to lie down and close one eye. Then you have to see the top of the tree. Mark the place where the top of the tree and the scale coincides. Let the value of the scale where it coincides with the tree be x. Now convert x decimeter to meter. That can be easily done by conversion 10 decimeter is equal to 1 meter. That meter is the height of the tree. Welcome to Scout and Scouting, where we learn scouting stuffs. Today in episode 11 of season 1, we will measure the width of a river via light sound method. For this, we need a sound source like a drum or steel utensils. Anything by which we can make sound. And at last, we need a stopwatch. We also need 2 persons in this method, including you. So let's get going. We need both of the scouts to stay at the 2 sides of the river. One of them will have the sound producer and let us consider him as A. The other scout is B, who will have the stopwatch. Now A and B have to be at the same line. At first, the A will make noise, and by saying that, B will start the stopwatch. Then B will stop the watch when he hears the sound. Now let the time in stopwatch be t. Then the width of the river will be t times 1120 foot or t times 340 meter. Welcome to Scout and Scouting, where we learn scouting stuffs. Today in episode 12, we will use light sound method to estimate height. Also in this episode, we need a drum or something to produce sound and a stopwatch. Along with these, we need 2 sticks which will be aligned at a 30-degree angle. We're considering one end as C and the other as E and D. Today we're estimating something big, which is a hill. First, we need a scout to go at the top of the hill with the sound producer. We're considering him or her as A. Then another scout B will place the 30-degree apparatus at a random distance in plain land. We also need to keep the stopwatch. By opening one eye, B will look at the CD of the apparatus. If he or she cannot see the top of the hill via CD, then he or she has to move backward or forward. When we see the top of the hill coinciding CD, then hold that position and give a signal to A to start the next step. At first, the A will make noise, and by saying that, B will start the stopwatch. Then B will stop the stopwatch when he hears the sound. Now let the time in the stopwatch be T. Then the height of the hill will be T times 1120 foot or T times 340 meter. Welcome to Scout and Scouting, where we learn scouting stuffs. Today in episode 13 of season 1, we will measure width of a river by compass method. For today's process, we just need a compass where we will ignore the needle and just focus on the 0 degree and 45 degree. At first, choose a static object at the opposite side of the river. In our case, it's the tree. Point that place as C. Firstly, we need to align the compass in such a way that the 0 degree is just at the tree. Consider that point as A. Remember, if we use a compass, just ignore the needle. Then move to the left until the 45 degree aligns with the tree. Let the place be B. Now that distance from A to B is equal to the width of the tree or equal to AC.